Hello guys, Oscar Hotel 8 Sierra Tango November here from Survival Tech Nord. After publishing the first episode of the Grid Down Communications for Preparedness series, it became blatantly obvious from the comments that people were concerned about actually powering up their communications gear in a grid down scenario. And thankfully, we spend an insane amount of time on this channel operating portable and out in the field. We take what we learn out in the field, using it to create an effective emergency power strategy useful at home and away from home. To be perfectly honest, the biggest challenge we have is convincing operators of the value of getting off-grid and in the field, since we often don't understand that relationship between operating off-grid and the grid-down scenario at home. This means we have an awful lot to cover in this video. So we need to start talking about batteries, we need to start talking about solar generators, wind turbines, solar panels, and alternative energy for both home and away from home. We also need to come up with a strategy which covers the voltage and charging requirements for the different types of radios we have. Now, in order for this video to become an effective learning tool for preparedness, we need to cover a lot of different topics. I'm going to do my best to do that, but I need you all to share your perspectives on what you've done so far. There's no wrong answers here, and everything we share can help someone. That's your job in this process. So, at the end of the video, we can use the comments to talk about what we've learned and how we've applied it to our own communications preparedness. So enough babbling. Stick with me, and let's get started.
You are listening to the Emergency Broadcast Systems. This station broadcasts emergency news and official information on the air for assigned area.
You know, emergency and portable power for our communications gear is a tough topic. We all have different types of radios. The radios have different charging requirements and different voltage requirements. And some popular radios have some pretty oddball voltage and charging needs. Thankfully, most of these problems are pretty easy to solve, but not in the heat of the moment, and definitely not with a gun to your head. For someone trying to figure it out, troubleshoot, and approaching this topic for the first time, it can be pretty overwhelming. So this is why we're attempting to put all of this information in one place. So if you don't mind, let's start this discussion by talking about our emergency and portable power strategy. Now, one of the most important things to understand is it doesn't matter what type of radio we're talking about. Amateur radio, CB radio, PMR radio, FRS radio, GMRS radio, it simply doesn't matter. What does matter is we understand how many volts and amps our radios need for powering and for charging. Once we have that information, it's pretty easy to design an emergency power system for our communications gear. To be successful with what we're doing here, these following questions are the most important to answer. What are the volt and amp requirements for my communications gear? Now we ask a similar question. How many volts and amps should I feed my radio when it's being charged? Does my radio utilize a DC input port or a charging dock, or both? Does my radio actually require external power to operate? How long should my emergency power or my power strategy power my comms gear? Once our grid down power is depleted, how are we going to recharge it? Now there's also a couple of other questions we might want to ask. For example, how much current does my radio use when it's just receiving? This question is directly related to the size or capacity of the battery we need and how long that battery will run our radios. Now, a related question is, will I primarily be operating high power, or what we call QRO, or low power, what we generally call QRP? This will help us to understand the battery capacity versus operating time arguments. Now, I know I talk a lot, guys, but it's important to understand you need to answer these questions if you expect to have a successful emergency power strategy for your communications gear. But hey, maybe we can take a more practical approach in this video, rather than me babbling on for the next 10 or 15 minutes. We can start with a basic overview of emergency and portable power system, then move on to several examples of the Go kits and how we power them. Each and every emergency and portable power system has a set of core components. That is a battery, a charge controller, the DC outputs we connect our gear to, and a means of charging up the system once it's depleted. For me, that's generally solar power. We can break these all down into storage, control, distribution, and charging. So battery storage is the first part of the system. Let's think about it as an energy reserve. It stores our collected energy for a rainy day, and it allows us to take that stored energy anywhere we might need it. From a communications perspective, the most common battery types are lead acid and AGM, lithium ion, or lithium iron phosphate. We'll get into the differences between these battery chemistries in later videos. The next part of the system is control, or charge controller. The charge controller serves 2 or 3 functions. Primarily, it serves as the interface between your charging apparatus, for example, a solar panel, a wind generator, or the alternator in your car, and whatever means you're using to provide power to your battery. It also protects our batteries from overcharge and over-discharge, which can result in reduced battery life or ultimately battery failure. Charge controllers are also like an extra set of hands. They do the work that we would normally have to do if we didn't have them. So now we can talk about DC distribution or power distribution. Power distribution is basically taking a source, in this case it can be a battery or a power supply, and splitting that DC source into multiple outputs which have the voltage we need for the devices we're connecting to our batteries. Unfortunately, power distribution is one of the areas which is most important but usually overlooked. DC distribution is important because it allows us to manage and organize the energy coming from our battery to our peripherals, our radios, our mobile phones, our shortwave radio, or whatever. It also allows us to place fusing between our power source, again a battery, and the individual devices we want to power with that battery. In this example, you can see I have my battery. I have a DC distribution cable with 2 DC outputs and 1 USB output. One of those outputs goes to my Yaesu FT817, while the other one goes to my Baofeng UV5R. The USB output can be used to charge my headlamp or my mobile phone or any other device which can be charged or powered through USB. Now we can see the DC distribution or output ports on my solar generator. The red and black ports are high amperage ports for radios or whatever type of equipment I might use. Of course, I have 2 USB ports, and the yellow and black ports are solar inputs. Now we can have a practical look at that solar generator's DC outputs when they're actually in use. So in this example, we're actually using the solar generator's DC outputs to power the Baofeng UV5R, or charging it, the Yaesu FT891 HF and 6-meter radio, the Kenwood D700 VHF and UHF, and a laptop. So closing down this DC distribution topic, DC distribution is the ultimate way of organizing what goes in and what comes out of your battery. And if for no other reason than the ability to easily troubleshoot your system, it's definitely worth it. Now we can move on to charging sources. So normally in a grid down scenario, the first thing that comes to our mind is a gasoline or diesel generator. Generators are absolutely magnificent for instant emergency power, as long as you're not powering your communications gear. My position on gasoline or diesel generators is definitely unpopular. My problems with them are they're loud, bringing unwanted attention, they create RFI or interference in our radios, and they will eventually run out of fuel. Again, that's just from a communications perspective. I definitely think we should all have generators. However, I think we should use them for rapid charging of battery packs when we don't have some other renewable power source, like wind or solar. It's becoming more common to see wind turbines deployed in the windy corridors of places around the world. What you may not know is that same wind turbine technology has been scaled down to a residential size, level, and budget. When we're looking at wind turbines for emergency communications, we shouldn't consider them as our primary emergency power source. As we all know, the wind isn't always blowing, and if it isn't blowing, a wind turbine can't charge or power our equipment. But what it can do well is augment our solar panels or other renewable power sources to make a more reliable emergency power strategy. Regarding pros and cons, the reliability of wind turbines depends on where you live and how much wind you get on average. There can also be a pretty steep technical learning curve in regards to integrating them into your existing emergency and portable power strategy. And this brings me to solar power. Now, if you've been around this channel for a while, solar power is probably the primary means of charging and powering my equipment. That doesn't mean solar power is the right choice for everyone, but it is working well for me at 65 degrees north for 8 out of the 12 months of the year. So currently I have 240 watts of fixed solar panels. I've got two 40-watt rigid panels up on the tower, which are good for about 4.75 amps in full sunlight. We also have the first of a set of 160-watt panels that we use to power our communications and ham shack. This single panel on its own is putting out about 9.5 amps in full sunlight. Now, we also have a collection of ultra-portable solar panels for field communications. We've settled on the PowerFilm Solar brand of portable solar panels, which are working pretty well for us. So of course we use these panels when we're deploying in the field. But if we go back to that word strategy we used earlier in this video, these solar panels are working triple duty for portable ops, for the car, and to augment our solar power at home. So the 240 watts of rigid panels we have up on the tower and in the yard are augmented by another 200 and something watts of portable panels, which can be deployed as necessary. So in the unlikely event that the wind isn't blowing and the sun isn't shining, we also have a pedal generator we use to top up our battery packs. Admittedly, topping up big battery packs with a pedal generator requires a lot of calories. But we are talking about a strategy after all. So by this point in the video, you have a pretty good understanding of how our emergency and portable power systems actually work. So now I think it's time to move forward, taking a look at some of the go kits common in the preparedness and amateur radio communities. Let's call this practical power. Now, despite my personal opinions, the Baofeng UV5R is definitely one of the most popular entry-level radios in the preparedness and amateur radio communities today. So this might very well be an excellent place to start our practical power discussion. So unlike many of the high-end radios in the amateur radio community, the Baofeng UV5R does not have an onboard DC charging port. Instead, its battery is charged and topped up through its charging dock. Now, that charging dock would be a heck of a lot more practical if it actually used 12 volts like we find in our automobiles or most of our batteries, or 5 volts like we find in our USB ports. Since it doesn't, we need to come up with a way of regulating the power that comes out of our battery packs to something which is compatible with the Baofeng charging dock. Now, there's a couple of different ways we can get power to the charging dock. Many operators are using this USB adapter to adapt 5 volts from a USB port to the 10 volts in the charging dock. This is called a boost converter. It boosts 5 volts from the USB port to the 10 volts the charging dock needs. I prefer not to use boost converters because in order to increase the voltage, they have to drop the amperage, which means your radio will charge slower. Even though that's true, the USB converter is the most convenient way of getting the right power from your power source to your Baofeng radio. Now, there is another way of achieving exactly the same thing without the loss of amperage. We call that a buck converter. A buck converter works to limit the voltage coming from your power source, dropping it down to the voltage you need. Now don't worry about the size of the one you see in the example now. They actually come in all shapes and sizes. This makes it easy to integrate them into your charging cable between your power source and your Bofeng charger. Now, unlike the Chinese radios, Japanese radios usually include a DC charging jack right on the radio. The jack or port usually has a wide voltage input, so you can plug your HT directly into your power source without using the charging dock or any type of adapters or converters. This built-in feature and functionality makes it easier to integrate your portable HTs into your emergency and portable power strategy. This also means your radio's charging or powering isn't dependent upon the cradle, which can be left at home or lost or whatever. This functionality also gives you the ability to tap a variety of different DC power sources, anything between 9 and 15 volts, without having to care about that narrow 10 volt requirement for the Chinese radios. Ultimately, it comes down to this. We're choosing between a budget entry-level radio, which is dependent upon the charging dock, versus a higher-end radio, which has a DC input built in and accepts a wide range of voltages. So let's take a look at some different radios and how we're going to power them. So this is my QRP radio from Yaesu. It's a pretty attractive radio for preparedness because it covers HF, VHF, and UHF, as well as having internal batteries. Since the internal battery pack for this radio doesn't provide a very long running time for this radio, we replace them with a higher quality of AA battery. So the first step is the internal batteries. We also want to extend its capabilities with an external pack. The second step in the power strategy for this radio is extending its runtime and capabilities with an external battery. We then combine that external battery with a charge controller, with a solar panel or foot generator, and with power distribution to power our communications gear from the disaster up until the recovery. Combined, these components make up our practical power for QRP communications. This kit includes a 5 amp-hour lithium iron phosphate battery, it includes a charge controller, and it includes a 20-watt solar panel. Now, to make this system complete, we need a couple of additional components. The first is a cigarette lighter adapter with power pole connectors. Now, we use this so that we can tap DC from a car or from some other type of solar generator or any DC power source. We can charge up our Powerpack or power the radio with it. The next is a DC distribution cable. So it has one plug for DC input, 2 plugs for DC output, and a USB port. Naturally, it also has a fuse. We can either connect this directly to the battery output or to the output on the charge controller when everything is connected together. It might be a good time to point out this same kit powers a lot of different devices, including my HT. Now, once again, this is about strategy. The same power system is powering up multiple devices from my Go kit. If you've been paying attention, you might also have realized that this is a basic solar generator. We have solar storage, we have a charge controller, we have power distribution, and naturally we have the solar panel. Now, what if your communication strategy was based upon operating high power? A 100 watt or 50 watt radio, for example. Now, we all know it takes a high amperage battery to start our cars or start our trucks. Well, it also takes a high amperage battery to power our communications gear when we're operating high power. Now, battery packs of this capability can either be custom built or commercially purchased. Now, even when we've obtained the battery is still just one component within a larger emergency and portable communications power supply. Because we really don't want just the battery. The battery by itself is only going to help us for a few hours at most. So we want to integrate the battery with all of the components that make up a system which produces power for us. But let's come back to this integration question in just a few moments. For now, let's look at things ensuring our batteries can supply the voltage and amps our high-power radios require. First on our list is amp rating if we're talking about lead-acid batteries, or C rating if we're talking about lithium batteries. A C rating or amp rating tells us the maximum amount of current our battery can deliver at one time. If we get this wrong, our radios won't be able to provide the amount of output power we actually expect them to. Next, we have to talk about the gauge of the wire, or the thickness of the inner conductor of our wire. The size of the wire, especially the inner conductor, determines the amount of current the wire can safely conduct. Basically, this means if we use a wire which is not adequate for the amount of current or load we have on the system, bad things will happen. So here's my primary radio. It's the Yaesu FT891 and I'm running it QRO. Underneath the radio you can see my solar generator. This is the 20 amp hour build I've recently showed on Instagram. Look at the wire coming out of the solar generator to power the radio. I'm using that 10 gauge wire between the power pole DC ports and the fuse box. Then between the fuse box and the battery, I'll use either 10 gauge or 8 gauge wire depending on the total load on the system. Now, even if you don't plan on building your own, it's important to understand how these things work because almost every solar generator or battery storage system for emergency backups is built in the same way. Now, to power the Yaesu FT891, which is a 100 watt HF radio, I have a 20 amp hour lithium based battery box or solar generator, however you'd like to call it, that I use to power this radio. As we've talked about all throughout this video, this battery box includes the battery itself, it includes the fuse block, it includes the power distribution, it includes USB ports, and naturally it also includes the charge controller. The reason we want to integrate all of these components into a battery box, creating a solar generator, is so that we're not fumbling around with wires and wire mess when we're trying to use our radios during a disaster. We simply plug our radios into this emergency power supply and start operating. It's also critical to point out your communications, whatever it is, CB radio, PMR radio, GPRS radio, FRS radio, MERS, they're all useless without an independent emergency power supply. And this actually brings us full circle, so let's go back to the strategy. Earlier in the video I told you the type of communications doesn't matter. Amateur radio, CB radio, MERS, GMRS, it doesn't matter. What does matter is we understand the capabilities and thus the requirements of our communications gear, and we come up with an emergency and portable power system to power our communications plan. Now, I believe our emergency and portable power system, or EPPS, should be standalone, even if that's just a small system for your QRP radio or handy-talkie. So try not to think about how big or how small the systems are. It only matters that we have standalone capabilities to power our communications. Now, I don't have the financial liquidity to go out and spend $1,000 or $2,000 on a solar generator. And I definitely won't take a loan for one, so my third option was building my own. On the left, we have a 45 amp hour or 576 watt hour solar generator. On the right side, we have a 20 amp hour or 256 watt hour solar generator. It's based on the same design as the 45 amp hour. I also have a smaller system specifically for my QRP radio. It's a 5 amp hour or 64 watt hour lithium iron phosphate battery. And like the other two systems, it includes a charge controller and solar panel. We can think of the radio and this power source as more of an evacuation kit. A completely self-contained kit designed to be used off-grid without the need to be charged through mains power. My larger solar generator powers my communications 24/7. They're constantly running. Now that's partially because I'm just a radio and communications fanatic, but it's also because I want to learn and understand about communications off the grid. One of the lessons of operating this way was the realization that we shouldn't be reliant on the grid in the first place. If we're designing our systems to be independent of grid electricity, a grid down scenario won't matter to us from a communications perspective. So I run my solar generators off of one 160 watt panel and two 40 watt panels up on the tower. That's how I run my communications at home. Now, if I'm operating portable or in the field for some reason, the 20 amp hour solar generator utilizes two 28 watt power film panels. Those are totally waterproof. The 45 amp hour solar generator utilizes a 120 watt folding panel from power film. It's also important to point out all of my emergency portable power is modular and portable. These portable panels also augment my home solar system. This provides some pretty good relief for the system during gray days or when I'm heavily using my communications gear. Now, more than anything else, having a standalone emergency portable power system allows us to put the power where we need it, when we need it, independent of the grid. When you start to think about it in these terms, it won't matter if you're operating in the field, if you're operating at home, if you're operating out of your car. It simply won't matter because your communications are already entirely off the grid. So this video is long enough, guys. We're going to do a follow-up video, but that video is going to be based on the questions you leave me in the comments of this video. Now, honestly, I could just keep going on about things related to emergency or emergency portable power. But instead, I'd rather hand the mic over to you and get your questions and answer them in the follow-up video. Also, don't forget to check the description, guys. It's usually filled with lots of useful information. So let's close it down. What should you have taken from this video? A dedicated emergency and portable power system for your communications gear. It should be independent of your other emergency power preps. And it should be made into an easy-to-use kit. If you don't take anything else away from this video, take this. Get your communications off the grid. Become grid independent. If you're supporting this channel through Patreon, PayPal, or simply sharing my content, you're absolutely magnificent and I couldn't do it without you. For the rest of you, if you like what I'm doing, if you like the content I'm creating, leave me a comment and a thumbs up to let me know. And if it's not too much to ask, please share this video with someone or someplace where other operators might enjoy it. Rock and roll, guys. Thanks for watching. Ciao.